Okay, welcome back. So now the mesh should be done. If you don't have a check mark here, go click update. It'll take a little while. And then launch setup, check double precision, and then do parallel processing if you have a computer that can do that and want it to go a little faster. Now opening up Fluent here, you can see the mesh we generated before. And now select axisymmetric and transient. And then for the models, we expect some amount of turbulence. So we'll change this to K epsilon, and the defaults are fine. Now for materials, there's a default fluid of air. Don't need to change that. And for the cell zones, this loads up. It's already air. Perfect. There's only one cell zone in this whole thing. For boundary conditions, most of these actually work by default as well. So the axis is our boundary condition at where the hub of the axial symmetry is. The wall is fine by default. And then this one needs to change to a pressure inlet. Set turbulence to 10%. And then a gauge pressure of 3,000 pascals. These also load in fine by default. We have a pressure outlet here. This is in red at 0 gauge pressure. So this just simulates sort of the rest of the room wherever this device is operating. Now the dynamic mesh. Check dynamic mesh. We want smoothing and remeshing. I'll go into settings here. We want diffusion type. Diffusion parameter of 1. So this is all about how the mesh is allowed to change and remake itself as it moves. In this case, we expect this mesh to come in, this CD to come in a fair amount. So the mesh right in here is going to need to change. How to determine those parameters? Not really sure, experimentally, I guess. So we want a 6 degree of freedom object. Create. We'll call this degrees of freedom for the CD. And even though it's a 6 degree of freedom object, that's the only choice. We're going to constrain it to 1 degree of freedom and translation only. Give it a mass of 15 grams, actually roughly the mass of a CD. And then constrain it to a direction, in this case, a vector along the positive x-axis. No spring preload, and we do want to constrain it. So we'll call the location it's in now 0, but then give it a minimum. So this is sort of giving it a backstop as the CD gets picked up. And we'll do 0, 0, 1, 2. It's allowed to and negative. It's allowed to come in 1.2 millimeters. And just to show it getting blown backwards at first, we'll give it a stop on the other side of 0.5 millimeter. In reality, if you're picking up a CD from the table, this should be set to 0. That it kind of looks cool for the simulation and illustrates the flow right at the start. So we can create this, close it, and give a gravitational acceleration of 9.81 positive x-axis. Okay, this looks good. And then we need to create dynamic mesh zones. So first, we'll do the CD, make sure this is selected here, and then 6 degree of freedom is on. These are fine by default. And then the other dynamic part needs to be the axis, and it needs to be deforming. Otherwise, the Ansys tries to keep the mesh exactly as is along this axis. So we just need to tell it that it is allowed to deform. So create this one as well. Okay. Moving on, we can initialize. Standard initialization is fine. Click initialize. Now it will let us do contours. Contour 1, call it the velocity contour. The pressure contour is also interesting if you want to add that as well. And we'll do velocity magnitude. That's good. And we have no velocity right now, so that looks good. Okay, and then now we can do a solution animation. And this will show a frame, and we'll select the velocity contour so we can actually see what's happening. Okay, looks like I need to name that something else. There we go. Okay, and then for the calculation, change some parameters here. Fixed time stepping is good. And for dynamic mesh, we found it's good to make a very small time step. So we're going to do 0.001. That is because sometimes if your objects are moving fast, the mesh can get ahead of itself and not really have time to update. And then the cell volumes can become negative, which creates an error and crashes your simulation. Do 100 time steps, give it 100 iterations per, report every 100, and profile update every 100. Okay, and we should be ready to run the calculation if I didn't forget anything. Okay, so I got this error before. And in classic Ansys fashion, if you close this, and we'll reopen it again, reestablish the degrees of freedom. And at least last time this worked. Who knows? So we may see an error pop up here about the degrees of freedom issue. Yep, we see the error here. So we'll go back to the dynamic mesh settings, So let's go through here. Establish this, create this again. Make sure this looks good. Okay. So sometimes it takes the degree of freedom away from this, and then you have to reselect it. I have no idea what's happening here, but I expect it to work now. Everything else that we had from before should have saved over. Now we can calculate and initialize. Now that's good. Okay, so now the solution is running. Takes a little while to run here. But we'll see the plate get blown back just a little bit, and then it will start getting taken up again as it gets picked up by the gripper. So a few things to note here. The interesting knobs to turn on the simulation, or at least what we found was interesting. You can change the inlet pressure boundary condition, and then you can also change the backstop and the front stop, which are in the dynamic mesh settings. Some combinations of those work well, and you can get some interesting oscillating behavior. Some combinations of those result in that negative cell volume thing if the simulation doesn't have enough time to update its mesh as it runs. And then in order to reset the dynamic mesh, so you end up with you know, the mesh in a different position at the end of the simulation, of course. So we can go ahead and stop this at the end of the next time step. You can see it's sort of starting to get picked up now. Okay. The way to reset it, and this is probably not the best way of doing it, but this is the only way that we found, was to quit. Go to setup, update, which does pretty quickly, and then launch it up again. Probably a better way of doing that. I don't know, but this works. And then you're back where you started before. Okay, and then it looks like we don't actually get the error for the 6 degree of freedom body again. So it looks like that was figured out. Anyway, that's it. There are plenty of things to play around with on this simulation. It's interesting to look at the velocity and the pressure profiles. There's a lot of interesting physics at play right here as the gas comes in. Through here, it's high velocity and then is shot out through the side.